So, yeah. So I'm the first person, I'm Jaimin Zaveri. I'm talking about polymers today. I'm working with Garda Chemicals, leading international marketing and application development. And I'm going to talk about these high temperature polymers today. Yeah, so you can see here this polymer material markets. So that is in till 2025, it is projected to be around 6,100 million US dollar, and it was only 850 million US dollar in 2015. So there is all type of polymer included in this, and the growth is more than 25%, and average YOY growth is minimum 20% in that. And as and when the polymer demand will grow up, these prices will go down, so that will be a very much balanced situation. You can see here some segments like why high temperature polymers or high performance polymers are important. So you can see here the contribution of the different industry segment in the growth till 2025. So especially all of us have talked today about the aerospace, biomedical, and automotive and consumer electronics. These industries will play, and they are playing a key role in this segment. And especially in polymers, we can see there are a unique requirement with the aerospace, as we know that fuel is a big cost, and it's a huge pressure to bring down the weight of the parts. So complex part and the structural part is the key requirement, and it is in next few years there will be 35,000 aircraft need to be built. So a lot of opportunities are there in this field. You can make brackets and interior parts, sockets, and all this kind of stuff. In automotive also, there is a trend of electric vehicles. So there also you have a high speed electrical vehicles in most of the automotive vehicles. And high speed and electric, that also required tribological and wear and friction resistance material and heat resistance material. You can see in biomedical segment also, many of our friends have talked today about these implant applications and surgical tools and many other applications today. But considering these future challenges, there are a lot of research going on, and we are also getting a lot of inquiries in terms of new developments, new blends with ceramics and polymer and different kind of nano composites and all this. So that is amazing field. And the one more field is consumer electronics. You can see this the development of 4G, and then now this China and some other countries are coming up with 5G. So with 5G and more high speed internet things, whatever electronics equipments are there, including mobile tabs and TV and all this, becoming more compact. When you make it more compact, you need to have a more high heat components, electronic components inside the device. So that's why this need of high temperature polymers will be very high in this segment. So, and you can see here, this is projected by Smart Tech and some other people, that the growth by this segment, aerospace, automotive, and the biomedical, it's phenomenal. It's 52%. This is in overall growth and this special materials growth. You can see here I'm talking about PAEK material. So this is you can see by this chart how PAEK material will grow till 2025. So that this overall PAEK market, including material, 3D printed parts, and in all form like filaments and everything, if you can include, it is estimated to be 1,000 US dollar, and this would be around 8 to 10% of the total polymer value of the total consumption. Here is most of the people, those who are here in polymer, they might have seen this chart, but this chart is prepared with reference to the additive manufacturing status. So you can see here there are amorphous and there is a crystalline. So most amorphous polymers are transparent and crystallines are non-transparent. So here this ground floor of this pyramid, where you can see polyethylene, polypropylene, ABS, and all these are all commodity plastics, very less cost effective, very cheap, and this is used for general purpose applications. These are already commercialized, widely available for filament market, and some of these materials are available in laser sintering also. On first floor, from ground floor to you can go to first floor, that is engineering plastics. So in that engineering plastics, you can see some of the materials are very unique material and it has a very high demand, like especially you can see PA 11 and 12. So that nylon 11 and 12 become a very very unique and very attractive material for the global market today, and it has been accepted by most of the segments. TPU is also one of the best material, and PETG and PES, PPS, PESU, and all these materials are fantastic. Now the difference between this ground floor and first floor, these ground floor materials are, the melt temperature is somewhere around 160, 170 degrees C. When you go to first floor, this engineering plastics material, this is in the range of 200 degree to 250 degrees C temperature. So that's why it is, on engineering in the middle band. Now I'm going to talk here on the top floor. So top floor you can see high performance engineering plastics material, where the melt temperature goes beyond the 300 degrees C. So that is 300 to 400 degrees C melt temperature. And along with that melt temperature, there continuous heat resistance in the application. So that continuous heat resistance is from 240 degrees C to 300 degrees C. So with unfilled material, it can withstand 240 to 60 degrees C, and when you add carbon fiber in that, it can go up to 300 or more than 300. So there is, a PAEK group. So in that PEEK, then PEK, PEKK, and ABPBI. And in right hand side, it is polyetheramide, which is a transparent material. ABPBI is one of the fantastic material. In top floor, ABPBI is not yet visible in 3D printing market. We are assuming and we hope that this material will come, because this material has the highest heat resistance. It can withstand up to 500 degrees C continuous temperature, and this is the only thermoplastics. Here you can see PAEK family members of the polymer, especially PEEK, polyether ether ketone, PEK, PEKK, and ABPBI. So first three are polyaryl ether ketones. So you can play with ether and ketone linkages and the ratio. And when you change the ether and ketone linkages, you can change the glass transition temperature, and you can play with this continuous heat temperature resistance and melt temperature, processability, stiffness, and all this. You can play around with that. You can see this unique chart. This is actual values, where you can see the polymer on the first column. So you can see PEEK, PEK, PEKK. So there are 4 different types of PEKK, which is amazing material for 3D printing. And you can see their glass transition temperature. It is very important for laser sintering, and whenever you are doing filament extrusion and all this, these parameters are very much important. Then you can see their melting temperature and initial decomposition temperature. So most of these high temperature polymers have decomposition temperature more than 500 degrees C. Advantages of high performance polymers, what are the special advantages? So it has outstanding chemical resistance, resistance to fluid and susceptible oils and gases, excellent wear and friction properties, and you can see very good tribological properties. The PV values are very good with all these materials, and the hydrolytic resistance is very good, outstanding thermal properties. So continuous service temperature, as I discussed, it is 240 degrees C to 300 degrees C you can achieve with this polymer. Excellent mechanical properties with good compressive strength. So for biomedical people, this is most important property. And even in many other applications of the textiles and gears and all these properties considered very well. Excellent radiation resistance. So we are the manufacturer of all this kind of polymer, and we have tested this material for this radiation resistance. And because it has an excellent radiation resistance, I've tested up to 200 megarad. This material can be used for defense application, and nuclear power plant and thermal power plant, ISRO. Like ISRO, we are one of the approved vendor in ISRO, and a lot of applications we have developed with the ISRO. So our material has been used for bus bar applications in the ISRO, and it is already there in the space. Excellent bone grafting properties. So you can see PEEK recently Evonik has introduced PEEK medical grade 3D printing filaments. PEEK is the material, and PEKK and PEK. This material has excellent fatigue and creep resistance. So that allows them to become a very stiff, and it's very lightweight compared to metal and other material. And this material has an excellent bond grafting property. So when you put this material with the tissue, the bone and these tissues are growing very fast. So that's why it's very much compatible with the bone. And there are a lot of blends, and there are other new composites are under place in the on a R&D stage, where you can see a lot of blends has been created with the ceramics and PEEK, and you will see a new product for the biomedical implants in future. Yeah, I will talk little bit in details about this PAEK, different materials. So you can see here the chemical structure of PEEK, polyether ether ketone. This is a semi-crystalline polymer. This is widely available. There are more than 5 to 6 manufacturers in the world, and that's why this material is commercially available. And PEEK is a material which has a melt temperature of somewhere around 340, 360 degrees C, and glass transition is temperature is somewhere around 140 degrees C. When this material is easy to process, so that's why these filaments are available in the market, and this material is quite widely visible in FDM filament type FFF technology. This material is very well visible, and this material is we have experienced that since there are a lot of manufacturers available, but even though this material is not visible in laser sintering application, so that is we are wondering. So we assume there is a limitation with this material in laser sintering, and that probably the crystallization behavior of this material. So there you can go with other aryl ether ketone materials. So this material is available in filament, and it's not in laser sintering. Another material is PEK. You have only one ether, polyether ketone. So you can see this material is also similar to PEK PEEK, but it has 20-degree continuous higher temperature than PEK. So when you are using PEK, you can withstand continuous 260 degrees centigrade temperature, continuous temperature, only with the unfilled material. And when you will use this material with the carbon fiber, you can go up to 320 degrees C continuous temperature. So that is amazing about this material. This material has a high temperature, melt temperature than PEK. So that is one of the limitation, because of when you want to process this material in extrusion for filament, you have to go up to 400 degrees C. When you want to extrude this material at 400 degrees C, you need to have a lot of heat control, and a lot of processing parameter control is required. That's why many people are not trying this material for filament, or maybe it's still not yet successful in making filament. So this product is not available in filament market or FDM market, but this product is very well available, and it is commercialized in laser sintering application. This is approved by Boeing and Airbus, and many components have been made with this material PEK. So that is where you can see EOS P800, it can process this material PEK. And this is the one of the challenge with this material with the laser sintering is that what we have seen is reusable, a refreshable powder. That is what in Europe people are using this word refreshable. In India we are selling reusable. So that reusage of the powder, after one cycle, that is a big challenge. So that wastage is 60 to 70%, and it's a huge cost. So, but still it has applications. And these are some comparison with the different metals. So it's almost comparable with the different metal by adding different filler in this. Then you can see PEKK. Now that's very amazing and interesting new generation material, and this will have a better future over all PEK material. We believe that this material will take over, other high performance thermoplastics materials place, because this will solve a lot of challenges. First of all, this material you can process at very low melt temperature. This is also a semi-crystalline polymer, but the beauty of this material is that you can process this material at only 310 degrees centigrade temperature. So it is easy to process in normal machines. You can extrude filament very nicely. This personally, I have taken this trial. This filament is golden brown, absolutely fantastic. We have printed this component and we will show this component here. Last week only we have printed and it's amazing performance. This material, the uniqueness of this material is it has a better, you can get a better sintering window in that. Because of this, it's TG and TM. If you have a broader difference between TG and TM, you have a broader sintering window. When you have a broader laser sintering window, you can play around with your laser sintering process parameters. So that's why it's very unique. This material is refreshable. Reusable is one of the biggest advantage. 100% you can reuse this material. There is no wastage. And it has a moderate crystallinity and excellent thermal stability with a continuous high temperature resistance. This material is very well visible and available in filament FDM market and laser sintering market. So that's a unique material. Another is polyetheramide, which is the brand name is Ultem, very much popular worldwide. It is owned by SABIC. SABIC is the inventor of this material. And this is a fantastic high temperature material. And this TG is 217, which is highest among these other thermoplastics. And absolutely low outgassing properties. And continuous temperature resistance is 190 degrees C with this material. And you can melt process this material at 340 to 350 degrees C. And this material is very well visible in filament FDM market, as well as it is in very much in advanced stage in laser sintering. And all these materials are approved by Boeing, Airbus, and a lot of other aviation OEMs. Polyether ketone. This is PEI, polyetheramide, yeah. So we have already discussed this, why high performance polymers for additive manufacturing in aerospace applications, lightweightening. So I don't want to repeat all this again and again. But I can say that you have, like you can see here, this advanced mobile and these biomedical implants and all this, that looks very attractive for Indian market because aerospace is yet to develop. But here we have a lot of projects with the defense, with DRDO, DSMRDE, then ISRO is there, and this NPCIL, BARC. So we are approved everywhere. So those who are the printer here or forward integrated people, we can help them because our material is specified everywhere. And we are the only company in India that we are into a raw material manufacturing, and we invested a huge money in that. And this will be a big benefit for the Indian people to compete with the global market. You just imagine if you want to import this material, the cost of this material is not less than 35,000 rupees per kg. We can give this, and this is with a 40% custom duty. We can provide this material locally. So that's a big benefit to the Indian industry. Dr. Garda is the founder of this company. He's a 90-year-old chemical scientist, known as the father of chemical in India. So he's still, working in our organization. Very, very much, he's a big inspiration for all of us. The other challenge with this is, at the moment people has to use stock shapes and bars and all these when they want to create some kind of new product. So prototyping is a challenge. So at this moment people are using stock shapes, bars and all these, and then they have to fabricate it. So that is a very crude method, and it's very costly. These stock shapes, when you are extruding a stock shape, this has a different properties. The quality is not so good compared to injection molding articles. And stock shapes is like, if you have PEEK or PEK or whatever material it is, for example, it is 4,000 rupees per kg. But when you buy stock shape, it is 14,000 rupees per kg. So that's amazing cost. Then again, you have to fabricate it. So again, 40% is a wastage. Then after fabrication, you have to do machining, polishing, assembly, and a lot of steps. What, Sri Devi Tools, my colleague has explained the steps of assembly and all this. So it's a huge cost. So just imagine, instead of that, you can use directly a material in a 3D printing and just prepare the prototype article directly. So that will save huge cost in that. This is a very interesting comparison. You can see a trend of injection molding to IM to AM, additive manufacturing. Recently, in Forum Next, we have seen some companies has announced this new technology. profusion technology by EOS. So that technology, it's amazing. I mean, you can make part in 9 seconds. So it is as faster as injection molding machine. And this chart shows that this is a practical chart. Then you can see this at this moment there is a status that if you want to make a part up to 18,000 or 20,000 numbers, then additive manufacturing is much more viable than injection molding machine. And if you want to go beyond that, or if you have 100,000 part, then obviously you can invest in the tool, and then you can go with the injection molding at this stage. But after next 2 years or 3 years, this trend will be changed. After 2 years, this graph will have to change to 100,000 numbers, because then this additive manufacturing will be comparable with the injection molding machine. You can see here cost comparison. You can see the cost comparison here. If you want to make a 20,000 parts, the blue color bar you can see here, that is the cost of the tool in injection molding machine. For one part I want to make with the injection molding. So that is the investment in the mold. Whereas you can see with the same part with 20,000 numbers, if I want to make the additive manufacturing, the cost is almost negligible. Now if you want to make similar part and the numbers are 1 lakh or 100,000 numbers, then you can see the tool cost will go down. And then it is comparable with additive manufacturing. But in further, one more column we will add, maybe in next 1 year or 2 years, that this will become half with additive manufacturing. So it will become a tool-free technology. That we are pretty confident on that. Huh? You are all. No, you can't replace all applications. This is a comparison for high performance things I am talking. You can't make ball pens with additive manufacturing. So this is a scenario you can see here what we have experienced is like filament FDM technology. So few years back, like 2-3 years down the time, when we have seen into the market, we have inquired to many machine manufacturers about FDM machine, and I did not get any supplier who can supply a FDM machine which has a more than 300 degree C temperature. I can count only few people like Robos and some other people in Germany, but nobody was available. So we have seen that the trend was 80% of the machines were able to process up to 250 to 220 degree C material. So it was limited up to nylon 11 and 12. But when you want to do a printing of the peak and all this material, there was no printer available. So now that ratio has been changed, and those days, like 2 years, 3 years back, there was a challenge of getting, filaments and the materials also. So no company was stepped into that field. So that was a challenge, and there was no advancement of this technology was not used for industrial production. It was only for prototyping. Currently, we have seen in Forum Next that this trend is changed. Now it is more than 50% people, they came forward, and most of them are offering a filament machine, FDM machine, which has more than 400 degrees C temperature. So that is a big encouraging sign for high performance polymer, because most of them are offering now 400 degrees C temperature. And you can see that most of the companies like Solvay, Garadas, Sabig, Arkema, BASF, they all came into this field and they started offering solutions, and they started supporting their customer to make filaments. Well, while I was talking with
Understand
BASF
from
people
Forum Next,
during
there
this
are
Forum
many
Next, it was
people
amazing numbers. I
saying that
understand.
is a
Maybe
big
it's right
market
or
of
wrong, but
filament.
I was told that in Europe itself, the polymer filament market is more than 15,000 tons. And just imagine this minimum price of any commodity polymer filament is 45 euro per kg. Now just imagine the market size there. Amazing. So that is, the market is now started growing there, and the trend will transfer to India very shortly, because we are getting a lot of inquiries. We are also coming up in this field. Many other companies are stepping into this, and this will grow. And you can see the future scenario. Future is more and more performance demand is there to replace metal in some critical part. You cannot replace metal 100%, but there are certain part where there is a need. And especially we have seen the need of composite part, carbon fiber field, glass fiber field, special nano composites and all these. So there, this future will become a more strong, and this 80/20 will change. I think 100% people will give a filament machine where you can run all kind of materials. Like FDM, the scenario in laser sintering is, laser sintering is I mean, when you compare this FDM and laser sintering, FDM is obviously is less costly, but laser sintering is very costly. Even their machines are very costly, and the powders are also very costly. This is a totally different game. But in laser sintering, we have seen this most popular materials are PEK, PEKK, PA11, nylon 11, nylon 12, and PEI. Nylon 11 and 12, I would say that there is a big players, Evonik and Arkema and EME and Ube and all these people are there. And 11 there is only one player, Arkema. But these are amazing materials. And out of this material, PEK, PA11 and PA12 are already commercialized. People are using this material. And in fact, I missed here, PEKK is also commercialized. You can see Advanced Laser Material, ALM, which is a division of EOS in US. They started making this carbon fiber fill PEKK material, and it has already been available in the market. The challenge with PEK is, I've discussed it, refreshable, reusable is a challenge in laser sintering. And the unique material again in laser sintering is PEKK, because we did a lot of research on this, and we are coming up with 100 tons plant of PEKK, and our plant will become operational in next 2 to 3 months. And this is an amazing material because of its crystalline behavior, very slow crystallization, and the cooling behavior is very nice, and you can handle this material at 320 degrees C. So earlier only P800 machine was there. Now you can process this material with P500 also, with EOS P500, and many other suppliers are also interested, where because this temperature range is very low, so you can see a more and more versatility of this material to be used by different laser sintering systems. Yeah, these are some idea which I have taken from this sources from statuses. You can see there is a comparison of this high temperature material PEKK. The orange one is PEKK, gray is PEI, and blue is normal engineering plastics ABS. So you can see the mechanical properties in different direction. This is XZ direction, and it is tested in ZX direction also. So the mechanical properties are fabulous with high performance material after printing. You can see this in other direction also. The properties are very good with PEI and PEKK. And similarly, you can see the comparison of the property with the heat deflection temperature and electrical properties are also very good. Now, what we can do, like Garda Chemical, as I said, we are the Indian R&D based organization, very patriotic company, and we are ready to serve global market. And we are now coming up with PEKK, and we would be happy to offer our filament grades. Three grades we have: 60/40, 70/30, and 80/20. So these are the G stands for granule, and here for laser sintering powder we have 3 grades for laser sintering powder, and we can also produce a customized grades also. If somebody has challenge and they want to modify the material, we have that capability to do a modification as per the customers. We can also do internal compounding, and we can give carbon fiber fill and milled or chopped carbon fiber or glass bead type of glass fibers or nano composite. We can do all this stuff. These are some applications of high temperature polymers, just to have an idea that what kind of applications are already exist in the market. So you can see various sources are mentioned here, and these are PEK. All these the second, third, and this is all PEK and PEKK parts. These are also PEKK parts for aerospace. Now you can't mold this kind of stuff. This is impossible. This is another first row and second row. These are all PEK parts, and this black one is carbon fiber filled PEKK by Hexel. They are supplying to Boeing, and it's a big demand for this material. These are some medical components. So first is, you can see Ultem. It's a medical sterilizable tray where the surgeons can put their tools inside and they can put into this boiling water or sterilization water and then take it out. And there are ortho and dental products as well. We have also made with our material this kind of components last week. These are automotive, especially in automotive, we are more working with the engine related part, gears and all this kind of stuff, and shaft and all this. This is our material which we have tested last week. So this is the first batch we have produced, and the granules we have extruded. We made a filament, and this is by FDM technology, and this material is printed by our friend Damara Gold. Now I am a goldsmith, the printer is goldsmith, and material is also looks like gold, so everything is gold. So Damara Gold is amazing people. Even though they are into gold, they have a separate company for 3D printing, and they are doing amazing work. They did a very nice printing, and within a first trial it went very well. There is no complaint, and it's a nice printing of this denture. This 0.2 layer is there. This is an aerospace bracket we have made here, and these components are available here if anybody wants to see that. This is we have made some rockets because we are working with ISRO, so we have some special projects with them. So I made this. We have also done testings of our specimens, HDT, flexural, and all this, and it's showing very good results. So these are some trial parts where you can see this different like 20% field, 40% field, 100% field, and what is the field ratio. This is by Damara Gold, and they have printing facility in Mumbai and Dubai, and you can see here what are the printing parameters. So it is just processed at 310 degrees C, only 310 degree temperature. Yeah, that's it. So if any question is there, you can ask. Yes, we can provide for trial. Hmm? Filament, yes. I mean, I have a very small sample available, and we are producing more filament in our internal R&D. We would encourage people to produce a filament itself, because we are a raw material company. Anyhow, we are going to make in our R&D as well, but we don't want to become a filament seller. I mean, personally, we would encourage these 3D printing people to take care of their jobs, because if we started doing printing and filament and all these, we don't want to compete with them. So we would like to support our customer. Yeah, we are a material supplier, but we have a filament produced in our R&D. So if you want, I can give you a small sample of that. Yeah.
Just last week we were discussing about PEK material.
Okay.
Being used for a soft tool. There's a proto tool that we are making, about 100 odd shots is needed. So we were thinking that whether we can use this insert as an insert in the mold for that particular application.
Oh wow, yeah.
Do you think it's possible?
Yeah, I mean, you have to share with us this technical requirement, especially temperature resistance. So what sort of temperature resistance is required? Otherwise, PEK, this material you can use as an insert. So that recently we did one project where it is being used as an insert for one of the submarine application under the water.
It works on the cyclic temperature minus
Yeah, up to minus minus 180 or minus 200 degrees C, we have tested it. There is a drop in mechanical property is by only 5% with minus 200 degrees temperature. So that is called cryogenic test. So that is, yeah, that has happened with our material. So that's not a problem. Yeah. Okay. Thank you.